Hello, I am Luis Miranda Kuner. My final degree project is called a low-cost and portable student ground station for tracking LEO satellites to promote capacity building in telecommunication area. The objectives of my final degree project will consist on implement a low-cost based software-defined radio receiving ground station for UHF band in order to decode CW signals from warranty TAT01. Then build a low-cost half-duplex ground station for VHF band in order to transmit receive packet radio to or from satellites. And once we design the two ground stations, so the main goal here is to promote studying telecommunication through satellites in school and universities. So the first model of the ground station is receiving ground station in order to decode CW signals with the objective to see the housekeeping data of the satellite that will consist to show us for example, the battery temperature, battery current, and battery voltage of the satellite. So the basic architecture of this will consist on UHF high gain JAG antenna, also a low noise amplifier that have around 20 or 30 dB gain in order to increase the signal to noise ratio. Also a software defined radio dongle with his proper graphical unit interface. And here on the right you can see the downlink budget that we calculated before in order to know if the downlink will be feasible or not. So we get a system link margin or 30 dB that allow us to implement our system, and on the left we can see the successful result when we catch a signal proceeding from satellites. So the warranty TAT01 is still in development, so we cannot test with it. So we test with another kind of satellite that has similar transceiver and similar mode of operation. In this case, we found the Birds 3 constellation has similar. So we implement our system and get successful result to decoding the housekeeping data. As you can see on the pictures, we try with the Nepalese SAT1 and Ravana 1. So the next model is about a half duplex packet radio ground station. In this case also we tried with the ISS, but we can try with another kind of satellite, and the basic architecture will consist on a high gain VHF JAG antenna, also a VHF handy terminal transceiver FM mode, and then the main component here is the terminal node controller, also called TNC, that you can implement by hardware or software, but both of them are low cost. The hardware you can implement by Arduino keys TNC, and by software you can first you need a sound card interface with your transceiver and your PC. So also we calculate the downlink budget, in this case for the ISS. So we use two criteria, the EB and 0, and because it's digital transmission, and also the signal to noise ratio criteria, and in both of them we get a positive link margin. So we implement our system and on the right you can see the successful result decoding packet radio. In this case was using the ECDG interface sound card, so decode the packet radio proceeding from the satellite ISS. The next one is the uplink budget. You can see on the left, also using the two criteria we got positive link margin on the two criteria, but still we have no get successful result, but we hope soon we can get them. In this case we suppose the worst case is possible because the lack of data of the ISS. We suppose a dipole antenna on the ISS and a system temperature of 1000 K. So the also main important here is to talk about the ground station implementation cost. The first model, the only receiving, will consist of testing with two different kind of software defined radio. We found the first one could cost around 144, and the other model will cost around 150. For the half duplex VHF ground station, we see also two options. One, each of them depend of the TNC that you implement. By hardware cost 192. This is cheaper than the implementing by software with the sound card interface that will cost 238. It's also important to mention that during our experimentation we carried antenna by hands and pointing to the satellite according to the position, according to the azimuth and elevation. You can avoid that using, for example, a base Arduino antenna tracking system. The SARCnet is well-known open source and software and hardware project for antenna tracking system, and you can build from scratch from around $512. So that will add to your budget for the first model to $1,688 and to the second model to $724. But this is still affordable prices for universities and schools here in Paraguay. So it's also important to mention that the Warning.01 has bring up too many opportunities to the students in many disciplines. One of these is a telecommunication student, for example, try to catching satellite signals here in the National University of Asunción, make their own antennas using the so different radio setups. Also, co-working and supporting to Paraguay Space Agency in building the ground station for the Warning.01. So also important to mention that I have my YouTube channel, and I often upload some recording signal when I trying to catch in LEO satellites, so you can find that. Okay, thank you for listening, and thank you very much.